Okay, here we are. We're going to watch old John Travolta's here. Now, my cat hated me. Poor thing. I had to put it down after 20 years. But anyway, the cat liked me, but for the most part, not a big fan when I do this. On a wintry day. Now, on a winter day, what happens is there's very little humidity inside the house because you got the heater going. All right, and so that decreases the humidity, so you don't have any of these water vapors around that will attach, as you chemists know, that little water molecules are polarized, and so little electrons will attach themselves to those things and make them neutral. All right, and so on a winter, when it's hot, or when you got the heat on in the house and it's dry, then you can kick up these electrons as dust. Essentially, is what you're doing. And so he walks across here and he kicks up these electrons, the dust of these electrons. And notice what these electrons do is they're forming. They spread themselves out evenly throughout, um, and we'll let them keep. If I left this on for a long time, we'd find that they'd eventually spread themselves completely evenly around. All right, but they do have a tendency to collect at points. We'll talk about that a little bit later. And then he comes up to this conducting doorknob, and look what happens.
Gazouch.
Gazouch. The electrons run to ground. Okay? They run to ground. Now, what happens? What happens then with a? So let's look at another download. This is a classic that you've seen a million times: balloons and static electricity. Okay. You've seen this a bunch too. Now look what happens. Here, notice positively, they're all neutrally charged. All of these are neutrally charged. And here's the wall. And we know that the wall is not a conductor of electricity. Neither is the sweater, really. But it's dry, and so we can go over here and we're going to scrape up a bunch of electrons off the sweater. All right? Then we're going to hold the oh, look what happens when we move the balloon over here. Whoop! It's attracted back to the sweater because the positive attractive force is too strong. But look what happens when I move the balloon over here. Look at those electrons moving away. The protons aren't moving, but the electrons are moving away, or basically it's ionizing, it's flipping over, and then it'll stick. Okay? Because these negative charges are attracted to these positive charges, so it'll stick. And then if I get it closer to where there's more positive, a stronger positive charge, which is to the left of the balloon, it'll attach over here. Okay, so you understand all that? Cool beans. All right, so those are your simulations. Now we can probably, I'll show you one other problem. We'll look at some of your homework problems from this next.